In this video, we will explain the binomial distribution. Let's start with a simple example. Suppose we flip a coin 5 times. And suppose the probability of head is 0.4. So the probability of tail is 1 minus 0.4, which is 0.6. Let x be the number of heads. Now we want to calculate what's the probability of observing exactly 2 heads, or the probability that x is equal to 2. Let's start with a simple example. If we observe head, tail, tail, head, tail. If we observe this sequence, then this sequence has 2 heads. What's the probability of observing this particular sequence? This is equal to the probability of this, and this is equal to, because each flip is independent, so this is equal to probability of head times probability of tail times p of tail times p of head times p of tail. Now recall that the p of head is 0.4, and we have 2.4 here. And the probability of tail is 0.6. We have 3.6 here. So this is equal to 0.4 squared times 0.6 cubed. Let's look at another sequence. If we observe a different sequence, for example, T, head, tail, tail, head. Now this sequence also contains 2 heads. What's the probability of observing this particular sequence? So this is equal to p of tail times p of head times p of tail, head here, times p of tail times p of head. Again, this is also equal to 0.4 squared times 0.6 cubed. Now imagine we list all of these possibilities, all the possible sequences that contains 2 heads, and we can see that each of these sequences has the same probability, which is equal to 0.4 squared times 0.6 cubed. So now, what's the probability of observing 2 heads? Then the probability of observing 2 heads is just the summation of all these probabilities. So to figure out what's the probability, we just need to figure out how many different ways we're going to have a sequence of 5 flips that contains exactly 2 heads. Now for that, we need the combinatorics. To illustrate the calculation, let's draw 5 slots. Now if I select 2 slots and put heads in it, and I put the tail in the rest, tail here and here, and you can see every time I choose 2 slots and put heads in it, that determines a sequence of head and tail that contains exactly 2 heads. So the number of ways we can have a sequence that contains 2 heads is the same as the number of ways that you can select 2 slots out of 5 slots. So the number of ways we can pick 2 slots out of 5 slots is 5 chooses 2, which is equal to 5 factorial divided by 2 factorial times 5 minus 2 factorial. This is equal to 10. Okay, so now, since there are 10 ways of doing this, now we can see that the probability of observing 2 heads, which is equal to the summation of all these probabilities, is equal to 5 chooses 2 times 0.4 squared times 0.6 cubed. And this is a probability that x equals 2. Now using the same argument, we can prove that the probability of x equals 3 is equal to 5 chooses 3 times 0.4 to the third times 0.6 to the second. And the probability x equals 4 is equal to 5 chooses 4 times 0.4 to the fourth, 0.6 to the first. So in general, we have this result. Suppose we run n independent trials. The probability of success for each trial is p, and x is the number of success. then we have the probability that x equals k is equal to n chooses k times p to the k times 1 minus p to the n minus k. This is also called the binomial distribution. X is called to have x is a binomial distribution random variable. Let's look at an example that we can apply this binomial distribution. An exam has 5 multiple choice questions. Each question has a unique correct answer out of 4 choices. One has to answer at least 3 questions correctly to pass the exam. What is the probability of passing the exam by guessing all the answers? Now let's suppose x is the number of correct answers. Now the probability of a pass is equal to the probability that x is greater than or equal to 3. And this is equal to the probability x equals 3 plus the probability x equals 4 plus the probability x equals 5. Now this is because if x is greater than or equal to 3, x has 3 possible values, 3, 4, and 5. Let's calculate these probabilities using the binomial formulas here. Now first, we can view each question, the answer for each question is one trial. And based on the assumption, we know that P is 0.25. The probability of success is 0.25 because there are 4 choices. And we have 5 questions, so you can think that we run 5 trials. So N is equal to 5. Now let's apply this formula here. So this is equal to 5 chooses 3 times 0.25 to the third times 0.75 to the second plus 5 chooses 4, 0.25 to the fourth, 0.75 to the first plus 5 chooses 5 times 0.25 to the fifth times 0.75 to the 0th. And this is roughly 10.4%. Thank you for watching.